There's a famous star that you've probably seen in the night sky, Betelgeuse. You can find it in the Orion constellation, marking Orion's right shoulder. Word on the street is that our beloved red supergiant might just be gearing up to explode in a supernova in the coming weeks. And let me tell you, both scientists and regular stargazers are losing their minds. Even Michio Kaku, the physics genius, is predicting that Betelgeuse could soon explode. If Betelgeuse does go supernova, it will likely be the brightest explosion humans have ever witnessed. But how bright are we talking? Could it be visible during the day? Would it pose any danger? Let's dive into some basic physics to figure this all out. The Betelgeuse phenomenon began back in late 2019 and early 2020, when Betelgeuse pulled a real dramatic move and dimmed so much that scientists thought it had already exploded. While we've always known it's near the end of its life, recent changes suggest it might be on its way out sooner than we thought. If it decides to go out with a bang, the phenomenon will light up the sky brighter than a full moon, and you'd be able to see it in the daytime for weeks, maybe even months. Now that's a spectacle. But hold on, before we grab our lawn chairs and popcorn, Kaku has raised some serious questions about what this supernova could mean for us here on Earth. Sure, it'd be jaw-dropping to see, but a supernova isn't just a pretty light show. These explosions unleash insane amounts of energy, radiation, particles, shock waves, you name it. And depending on how close and how powerful the blast is, there's a chance it could mess with Earth's atmosphere in some not-so-fun ways. So what's the big deal if Betelgeuse decides to go supernova? Well, one of the biggest worries is the possibility of gamma rays and cosmic rays crashing the party. Now, gamma rays in large doses could do some serious damage to Earth's biosphere. But before we start panicking, remember this: Betelgeuse is chilling 640 light-years away. That's far enough that most of the gamma radiation would fizzle out before reaching us, thankfully. Still, Kaku warns that even though we're not in for a gamma ray apocalypse, we could see some problems up in the atmosphere. Imagine satellites giving up, GPS systems sending you to the wrong Starbucks, and electrical grids acting weird, all thanks to that extra radiation. And then we have cosmic rays, which are even more dangerous than gamma rays. In fact, they can actually penetrate Earth's magnetic field and atmosphere. Sure, most of them get deflected, but an increase in cosmic ray intensity could be bad news for humans. Frequent flyers and people living in high-altitude areas could face some serious health issues. Plus, these rays have a knack for messing with electronics, meaning your phone, laptop, or even major tech systems might glitch. Now, before we all start stockpiling sunscreen for gamma rays, scientists like Michio Kaku want us to take a deep breath. Despite all the buzz, the potential explosion of Betelgeuse is more likely to be a scientific jackpot than some doomsday scenario. The treasure trove of data we could collect from watching this supernova up close could finally answer some of the universe's biggest mysteries. How do stars blow up? What's the deal with stellar evolution? And how do these cosmic events shape galaxies and possibly even life as we know it? This would be a game changer for astrophysics. I mean, we've never had the chance to observe a supernova so close to home, and it's not just about science. For thousands of years, this red giant has been woven into the myths and stories of cultures all over the world. So if it suddenly explodes, that's a major plot twist. This explosion would also be a mind-blowing reminder that the universe is constantly changing. Birth, death, rebirth, rinse, repeat. And let's be real, there's nothing like a star exploding 640 light-years away to remind us just how fragile our little blue planet is. Who knows? Maybe it would even spark conversations about how we need to take better care of Earth. Now here's where things get really interesting. Kaku is saying that this supernova could happen in just 2 weeks. Yeah, that's right, 2 weeks. If true, that means astronomers have spotted some serious red flags with Betelgeuse's behavior. Maybe it's acting all weird with its brightness shrinking or throwing out radiation. These shifts could be the clues we need to finally nail down how and when a star reaches its explosive end. But hey, let's not get too ahead of ourselves. Predicting when a star like Betelgeuse is going to blow is about as reliable as predicting the weather 2 months from now. Sure, the star is definitely on its way out, but it might just drag out its farewell tour for decades or even centuries. So while Betelgeuse's recent antics are exciting, they don't guarantee that we're about to witness the grand finale anytime soon. Now, if you think only scientists are hyped, think again. The public is just as eager to watch this unfold. News channels, social media influencers, and science nerds are all gearing up to break the internet with real-time updates and facts about the event. This isn't just a nerdy sideshow. People might actually gather in parks or set up viewing parties for the greatest sky spectacle of all time. Who needs New Year's Eve fireworks when you've got a supernova lighting up the night sky? But here's the thing. Even though everyone's pumped for this potential explosion, it's also a huge reality check that the universe is one wild and unpredictable place. Those stars we stare at every night, they're not just pretty and constant. They're out here living their best chaotic lives. Betelgeuse going boom would be the ultimate reminder that everything up there is in flux, evolving and occasionally blowing up in the most dramatic way possible. As we wait with bated breath, Michio Kaku's prediction has left us all wondering, will this be the cosmic showstopper we've been waiting for? Or will Betelgeuse decide to take its time and make us wait just a little longer? Either way, the potential explosion isn't just a wow moment for Earth. It's a chance for humanity to witness something astronomically rare. A supernova that could teach us more about the universe than we ever thought possible. If you thought exploding stars were just about a bunch of light and some cool space dust, think again. A supernova is basically a star going out in such a blaze of glory that it releases more energy in a few seconds than our sun will in its entire lifetime. Yeah, that's right, it's like comparing a campfire spark to an atomic bomb. These events shape entire galaxies, spit out the heavy elements that form planets, and let's not forget, everything from the iron in our blood to the gold in your grandma's wedding ring. That's all thanks to exploding stars. When a star like Betelgeuse runs out of fuel, its journey toward a spectacular end begins with the halting of nuclear fusion at its core. This signals the collapse of the star's core under its own immense gravitational pull. For a star as large as Betelgeuse, this core collapse triggers a dramatic explosion known as a Type II supernova, a cosmic event so violent that it rips apart the star, launching its outer layers into space at mind-blowing speeds. The matter ejected from the explosion is rich in life-essential elements like carbon, oxygen, and iron, the same building blocks that form stars, planets, and ultimately life itself. Betelgeuse going supernova, as Michio Kaku suggests, could completely reshape our understanding of stellar explosions. Astronomers would be able to collect data on how the shockwave moves through the star's outer layers, something rarely observable because most supernovae occur in distant galaxies. By the time their light reaches Earth, we've missed the critical early moments of the explosion. But with Betelgeuse just 640 light-years away, it could provide an up-close view of this cataclysmic process. This explosion would also offer multi-wavelength data for scientists, allowing them to observe the supernova through visible light, infrared, ultraviolet, X-rays, and radio waves. Each wavelength would peel back a different layer of the star's energy. Infrared observations could track the cooling and condensation of dust and gas post-explosion, while ultraviolet and X-rays would shed light on the shockwave's interaction with the star's outer atmosphere. Meanwhile, radio waves might capture the synchrotron radiation, the accelerated particles hurtling through space, providing a more detailed look at the underlying dynamics of the explosion. This multi-wavelength approach could rewrite current supernova models, which are largely based on data from faraway explosions. While these models have been incredibly useful, they're limited by how little we can observe from distant supernovae. A Betelgeuse supernova would break that barrier, giving scientists real-time, detailed observations that could revolutionize our understanding of massive star deaths. And then comes one of the most common questions: what will Betelgeuse leave behind after its explosion? Depending on its mass, the star could collapse into either a neutron star or a black hole. If it's on the lower end of the mass spectrum for stars that go supernova, Betelgeuse may become a neutron star, a superdense, rapidly spinning core made up of neutrons with a mass like our sun packed into a ball just a few kilometers wide. Neutron stars are among the universe's most exotic and fascinating objects, with incredibly strong magnetic fields and gravitational forces. But if Betelgeuse is more massive than anticipated, its core could collapse further into a black hole. Black holes are even more mysterious, with gravitational fields so intense that not even light can escape. If a black hole forms, scientists could witness the birth of this extreme object up close, offering unparalleled insights into one of the most enigmatic phenomena in the cosmos. Although black holes cannot be directly observed, scientists can detect their presence through the effects they have on their surroundings. In the case of Betelgeuse, if its core collapse leads to the formation of a black hole, it would create gravitational waves. Additionally, as material from the star is drawn into the black hole's event horizon, X-rays would be emitted, providing further evidence of its presence. Such observations would be groundbreaking, allowing scientists to study black hole formation in real time. Beyond the scientific excitement, the explosion of Betelgeuse could have deep cultural and philosophical implications. Throughout history, humans have often interpreted the sudden appearance or disappearance of celestial objects as omens or significant signs. Even with modern understanding, witnessing a supernova of this magnitude would likely result in some emotional and psychological response. The sheer brightness and unusual nature of the event, visible to the naked eye, would remind us of the awe-inspiring and unpredictable forces at play in the universe. The supernova would likely become a global spectacle, drawing people from different cultures together in shared wonder. At the same time, it could prompt deep reflection on humanity's place in the universe. On a practical level, Betelgeuse's supernova would likely lead to a massive scientific mobilization. Telescopes like Hubble, the James Webb Space Telescope, and the European Southern Observatory's Very Large Telescope would be among many instruments trained on the star. Agencies like NASA, the European Space Agency, ESA, and private space research companies would collaborate, pooling resources and expertise to capture as much data as possible. There may even be dedicated missions launched to study the supernova, taking advantage of this once-in-a-lifetime opportunity. Betelgeuse's explosion could also drive advancements in high-energy astrophysics. Supernovae release vast amounts of high-energy particles such as neutrinos, which are incredibly difficult to detect due to their near-massless nature. However, a supernova would flood the universe with neutrinos, giving scientists a unique opportunity to study them in greater detail. Additionally, the event would allow for deeper insights into the behavior of magnetic fields and the mechanics of extreme physics, offering an invaluable contribution to our understanding of the universe's most violent and energetic processes. Neutrino observatories around the world, such as the Super Kamiokande in Japan and the Ice Cube Neutrino Observatory in Antarctica, would be closely monitoring for any neutrino signals originating from Betelgeuse. Detecting these neutrinos would provide direct evidence of the processes occurring in the star's core during its collapse. Since neutrinos travel nearly at the speed of light, they could potentially serve as an early warning system, alerting scientists to the explosion even before the light from the supernova reaches Earth. Betelgeuse's supernova and its scientific impact. While the initial explosion would certainly captivate global attention, the long-term scientific value of this event may prove to be even more significant. The remnants of the supernova, the gas, dust, and heavy elements ejected into space, would continue to be a subject of study for decades. If not centuries, this material would form a nebula, an expansive cloud that could act as a laboratory for understanding the processes of star formation and the recycling of matter in the universe. Over time, this nebula could give rise to new stars and planetary systems. The materials ejected by Betelgeuse could also yield insights into the chemical elements essential for life. Supernovae are responsible for producing many of the elements found in living organisms, such as carbon, nitrogen, and oxygen. By analyzing the composition of the materials ejected by Betelgeuse, scientists could better understand how these elements are formed and distributed throughout the cosmos. This knowledge could enhance our search for life on other planets as we gain insights into the conditions necessary for these crucial elements to emerge. One significant aspect to delve into is the role of Betelgeuse's supernova in advancing our understanding of fundamental forces, particularly gravity. As a massive star, Betelgeuse's core collapse would dramatically alter the fabric of space-time. For decades, scientists have sought to study gravitational waves, ripples in space-time first predicted by Albert Einstein's general theory of relativity. Although gravitational waves were directly observed for the first time in 2015, most of those observations have involved events like the merging of black holes or neutron stars. A nearby supernova, such as that of Betelgeuse, would offer a unique opportunity to study gravitational waves generated by the core collapse of a dying star. Another intriguing effect of Betelgeuse's explosion is the study of magnetism in the aftermath of a supernova. Massive stars like Betelgeuse possess powerful magnetic fields, and the core collapse during an explosion can amplify these fields to extraordinary levels. If Betelgeuse forms a neutron star after its explosion, it may give rise to a particularly exotic type of neutron star known as a magnetar. Magnetars are fascinating objects that emit bursts of X-rays and gamma rays, and studying a magnetar that forms from Betelgeuse's collapse could unlock important insights into the mechanisms behind these emissions. Betelgeuse's explosion could generate complex organic molecules. While the chaotic environment following a supernova is unlikely to directly foster the emergence of life, these molecules might offer clues about prebiotic chemistry, the processes that can lead to the formation of life. Observations of the supernova's remnant could reveal how these complex molecules form and survive in the harsh conditions of interstellar space, contributing to our understanding of life's origins in the universe. A crucial factor for scientists to explore is the supernova's influence on the interstellar medium, the vast expanse of gas and dust between stars. Supernova explosions are primary drivers of turbulence in the interstellar medium, creating shock waves that compress and heat nearby gas clouds. This compression can trigger the collapse of these clouds, leading to new star formation. Betelgeuse's explosion could potentially initiate a wave of star formation in the surrounding regions of the Orion constellation, where it resides. The study of star formation following a supernova is an active area of research, and a nearby supernova would present a unique opportunity to observe these processes in real time. By monitoring how Betelgeuse's shockwave interacts with nearby molecular clouds, scientists could gain valuable insights into the conditions necessary for star formation and the role supernovae play in birthing new stars and planetary systems. The Orion constellation is already renowned as a stellar nursery, home to several regions of active star formation. Betelgeuse's explosion could further accelerate these processes, adding complexity to this dynamic region of the sky. The potential formation of new stars raises the exciting possibility of studying planetary system formation in the aftermath of a supernova. Although it may take millions of years for new planets to develop around these newly formed stars, the materials ejected by Betelgeuse could serve as essential ingredients for these planetary systems. By examining the composition and distribution of this material, scientists could enhance their understanding of how planets form and the conditions necessary for developing the characteristics required to support life. While the excitement of witnessing such a nearby supernova is clear, it raises essential questions about how humanity would respond to this event. Our modern society is heavily reliant on technology, and the explosion of Betelgeuse could disrupt satellite communications, power grids, and other critical infrastructures. Although the distance means catastrophic damage to Earth is unlikely, the potential for technological disruption underscores our vulnerability to cosmic events. The study of space weather, how solar activity and cosmic phenomena affect Earth's technological systems, has gained importance as our reliance on satellites for communication and navigation has grown. A nearby supernova could yield valuable data on how high-energy radiation from space interacts with Earth's atmosphere and magnetic field, enhancing our ability to predict and mitigate the effects of such events on our technology. This knowledge would be crucial for preparing for future cosmic occurrences, such as solar flares or supernovae elsewhere in the galaxy. This event could serve as a reminder of the interconnectedness of all things. The same processes that lead to the death of stars also create new ones, and the elements produced in these explosions are the building blocks of life itself. As humans, we are made of the same elements formed in the hearts of dying stars. The explosion of Betelgeuse could be a powerful reminder of our origins and our place in the universe.